Hey there guys. So in this video we're going to start applying what we know about linear equations to some real world examples with the goal of eventually, not in this video but the next lesson, taking some real world data and using it to make predictions. But here we're just going to go to the basics and talk about how we can write linear equations to represent some real world scenarios, starting with number one. So we have a cab ride here, and we know that the cab ride costs $4 plus $1.75 per mile. So part A asks us to write an equation to represent the cab fare, and we always start equations by defining our variables. So in this equation we're going to have an x and a y. The x is our independent variable and the y is our dependent, meaning the value of y is going to depend on x. And so let's think about what we're measuring x and y in. We have a rate in this problem. Okay, we know it costs $1.75 per mile. The rate of change is similar to the slope when you have a linear function. Okay, the rate of change always relates the y value to the x value, or the dependent to the independent variable. So in this case, the number of miles, okay, this is the part that comes after the word per, is our x value. And then the cost, or the cab fare is what we could call this, would represent our y value, or our dependent value. Okay, so the cab fare, or the cost, depends on the number of miles you ride. Okay, so that's how we can start out our equation. Okay, let's now think about what this all means together. So $1.75 per mile is our rate of change. Another word for rate of change is slope. Okay, the rate of change of a line is simply its slope. So this 1.75 here, this $1.75 is simply our m value if we're talking about linear equations. Okay, it's our slope. The $4 is what we call a flat fee, meaning we pay this no matter what, no matter how many miles we've driven. This is our starting cost. Okay, starting costs or starting values can always be related back to your b value or your y-intercept of a line. Okay, it's where you start, assuming that your independent value is 0. You pay this $4 no matter what. So an equation for this scenario might be y equals 1.75x, $1.75 per mile, plus 4, plus the $4 you pay initially. Notice this is a slope-intercept form equation that we've written here. So now in part B, we're going to take this equation and we're going to try to answer the question that says if Clayton's destination is 17 miles away and he has $30, will he make it? Well, this 17 right here represents our number of miles, or our x value. So let's just take our equation and let's see what we get for y, or the cab fare, when x is 17. So we're going to plug in 17 for x to this equation. So when we do that, 1.75 times 17 is 29.75. And add 4 to that, we get 33.75. So what that means is if you go 17 miles, it's going to cost $33.75 to go that total distance. So the answer to this question is, since Clayton only has $30, no, he does not have enough money. Okay, number 2 says the Joneses are purchasing a new home. The closing costs are $249 plus 3% of the purchase price of the home. And so in part A, again, we're going to write an equation to represent this situation. Now, it's perfectly fine if you use x's and y's for all of your equations, but feel free to be creative. Not every linear equation you see is going to have just x's and y's. Okay, sometimes you'll see other variables used to represent the same idea. Again, an independent quantity and a dependent quantity. Now for this problem, it might be good to understand a little bit about what closing costs and purchase price mean. Okay, so Closing costs are simply the fees that you pay when you work with a realtor. Okay, so if you go to buy a house someday and you work with a realtor to help you find a house and purchase it, you will be paying that realtor or that company more than just the price of the house. You'll be paying them a certain fee depending on typically how much the house costs. The purchase price is simply how much you're paying for the house itself. Okay, so our two variables for this problem could be the purchase price and the closing costs. And the closing costs are dependent on the purchase price, so we could let our X value be the purchase price and our Y value be the closing costs, or we could even assign different letters to both of those, and we could say let P equal the purchase price and C equal the closing costs. And so now, to write an equation for this, we can just look at this last sentence here, which says the closing costs, which we know is C, are equal to $249, so that would be $249, plus 3%. Remember, 3% when we put it in equations needs to be written as a decimal, so that would be 0.03, 3% of the purchase price, and we said the purchase price is P. So this equation is C equals 249 plus 0.03 P. And now we'll use this equation to answer the question in part B. This question says the purchase price of the home is $195,000. The sellers offered $5,000 in closing cost assistance. And the question is, will this cover all of their closing costs? If not, how much will the Joneses need to pay out of pocket? So first of all, let's determine what the closing costs are if the purchase price of the home is $195,000. So this is telling us that P equals $195,000. So what is C? So we're going to substitute $195,000 in for P. .03 times 195,000 is 5850, and so we add our 249 to that, and we get $6,099. So the closing costs for this price of a home would be $6,099. So that means that the Joneses are going to have to pay a little bit out of pockets because the sellers, okay, the people letting the Joneses buy their home, are only covering $5,000 of those closing costs. And so if we take the difference between $6,099 and $5,000, we will find how much the Joneses have to pay out of pocket, which is $1,099. Okay, number 3 says a 22.5 ounce candle burns at the rate of 1 ounce every 5 hours. So for this problem, again, we have a rate, and we can see that the rate is 1 ounce every 5 hours. Okay, even though I don't see the word per in here, we could replace every with per, 1 ounce per 5 hours. And so the independent variable, which is going to be our first let statement, is going to be what comes after this per or every, and this is the number of hours. The dependent variable would be the number of ounces. Again, it's ounces per hour, okay, Y per X. I can use an X and a Y for this, or I could say let H equal the number of hours, and I could say let C equal the number of ounces, or the amount of the candle left. So an equation for this one, the number of ounces that the candle has at any time, well, we're going to start with a 22.5 ounce candle, so that's our starting value. We are losing, so this is going to be a minus sign, 1 ounce every 5 hours. So if it's 1 ounce every 5 hours, then let's think about how many ounces are we losing per 1 hour. Well, we would be losing 1/5 of an ounce every 1 hour. So my rate of change would be minus 1/5, and that's per 1 hour. After 5 hours, we've lost 1 full ounce. So that would be our equation for this problem. Part B is asking us to find how many hours will the candle last. So this is asking us to find H, okay, and we're going to assume then C is 0. So what is H when C is equal to 0, when there's no more candle left? Well, let's figure that out. We're plugging in a 0 for C and solving for H. So we can subtract 22.5 from both sides, and then multiply both sides by -5. -5 times -22.5 gives us 112.5. So that means that this candle will last 112.5 hours. Okay, so these were all examples of equations where our problems where our equations ended up being in slope-intercept form. Okay, where we had the y equals mx plus b form, even though we may not have been using a y and an x in the equation. Going on to the back side, we'll take a look at some examples where we might use standard form to write the equations. And so number 4 is an example of this, where it says Josh bought 3 bags of potting soil and 10 bags of mulch from Home Depot. And for part A, we need to write an equation to represent the total cost. Okay, well, the total cost is going to depend on a couple of different factors. It's going to depend on, number 1, how much does a bag of potting soil cost? So we could say let P equal cost of potting soil. The cost is also going to depend upon what's the cost of a bag of mulch. Okay, a bag of mulch is not necessarily going to cost the same as a bag of potting soil, so we need to put that as a second variable. And the issue here is neither one of these is your dependent variable. Okay, so the cost of the potting soil does not determine the cost of the mulch and vice versa. We actually need a third variable to represent the cost that we pay, okay, or our total. So I could just say let T equal total, okay, the total amount I'm going to pay for the potting soil and the mulch. And so it's from these variables this is where I get my standard form equation. So we know that we're buying 3 bags of potting soil. So if they cost P dollars per bag, then the cost for just the potting soil is going to be 3 times P, or 3P. We're buying 10 bags of mulch, so the cost for the mulch is going to be 10 times M. And if I add those two subtotals together, I get my total cost, which right now we're just calling T. Okay, so this is our equation, 3P plus 10M equals T. And so now we're going to use this equation in part B, which says if Josh spent $40.91 and mulch cost $2.75 per bag, how much was a bag of potting soil? So we've been given two variables here now. We've been given the total, T, $40.91, and we've been given the cost of mulch, $2.75. So I can take both of those, substitute them into my equation, and solve for my other variable, P. So if I solve this equation, I get 3P plus 2750 equals 4091. I subtract 2750 from both sides, I get 3P equals 1341. And then if I divide both sides by 3, I get P equals 4.47. So that tells me that potting soil is $4.47 per bag. Okay, number 5 says Kaylee has a collection of quarters and nickels. We need to write an equation to represent the total value of the coins. Okay, so I don't know how many quarters or how many nickels I have, or how many Kaylee has, excuse me. So we could say let Q equal the number of quarters, and we could say N equal the number of nickels. And again, if I combine the number of quarters with the number of nickels, I'm going to get my T total dollar amount, or total value. Okay, so we're writing an equation to represent the total value, meaning this is in terms of dollars. So you have to think, how many dollars is 1 quarter worth? Well, it's worth $0.25, 25 cents. So my equation could be 0.25Q plus the value of a nickel is 5 cents, 0.05, times N equals my total dollar amount, T. So now we can use this equation to answer part B's question, which says if the total value of the coins is $5.50, here they're giving us our total, and Kaylee has 17 quarters, here they're giving us the Q value, how many nickels does she have? So substituting 17 in for Q and 5.5 in for T, we can find N. So this is 0.25 times 17 plus 0.05 N equals 5.5. 0.25 times 17 is 4.25. I can subtract 4.25 from both sides to get 0.05 N equals 1.25. And then if I divide both sides by 0.05, I get N equals 25. So we have 25 nickels. Or Kaylee has 25 nickels, should I say. Okay, for the last problem, I would like you to try this on your own, and then we will check your answers the next time I see you in class. So try number 6 on your own. We'll go over that one the next time I see you in class. Until then, folks, have a nice day. You're all wonderful people. Take care.